Welcome to the DIY Honda Garage channel. The DTC P0703 refers to a malfunction of the brake pedal position switch, specifically noting a failure in the normally closed NC mode. This indicates that the switch is not providing the necessary signal to the Powertrain Control Module, PCM, which controls various aspects of the vehicle's engine and transmission functions. The brake pedal position switch is pivotal for the vehicle's safety and proper operation, determining whether the brake is applied. It is typically located near the brake pedal assembly inside the vehicle's interior beneath the dashboard. When the brake pedal is depressed, the switch sends a signal to the PCM, which then allows the vehicle's cruise control system to deactivate, along with other critical safety features. If this signal is not detected correctly, it could result in erratic vehicle performance and potential safety risks. Thus, the accurate recognition and rectification of this code are essential for the reliable functioning of the Honda Fit. The brake pedal position switch plays a crucial role in monitoring the engagement of the brake pedal. This switch sends signals to the PCM to indicate whether the brake is being applied. If the switch malfunctions, the vehicle may not respond appropriately to braking, leading to a hazardous driving situation. In the Honda Fit, this switch is typically located at the pivot point of the brake pedal mechanism, making it easily accessible for inspection and replacement. The failure of this switch can lead to numerous issues, including the potential for the cruise control not disengaging when the brake is pressed, which might cause an unexpected acceleration. Understanding where this component is situated and how it impacts vehicle functions is vital for effective troubleshooting and repair. There are several possible causes for the DTC P0703 error code. One primary cause could be a faulty brake pedal position switch itself, which may not be responding correctly or may have internal failures preventing it from sending an accurate signal. Another potential issue can stem from wiring problems, such as short circuits or open circuits within the wire harness that connects the switch to the PCM. These wiring problems can disrupt the communication between components, leading to the malfunction. Additionally, a blown fuse may cause the power to the brake pedal position switch to be interrupted, hindering its operation. Identifying these possible failures is critical, as it helps streamline the troubleshooting process and minimizes unnecessary replacements of functioning parts. Several symptoms may be associated with the DTC P0703 error code, highlighting the importance of immediate attention. One prominent symptom is the malfunction of the cruise control system, which may not deactivate when the brake pedal is pressed, posing a significant safety risk. An inconsistent brake signal being sent to the PCM can also manifest, which may lead to erratic vehicle behavior or failures in automatic transmission operations. Furthermore, the dashboard may illuminate warning lights, alerting the driver to a potential issue needing prompt resolution. Collectively, these symptoms not only indicate a malfunction, but also emphasize the critical importance of the brake pedal position switch in overall vehicle operation. The first troubleshooting step for addressing DTC P0703 involves placing the vehicle in the on mode and utilizing the Honda Diagnostic System, HDS, to check specific parameters without pressing the brake pedal. It is essential to assess the readings for signals like cruise brake SW idle and stop SW. The goal is to determine if the current conditions match the expected thresholds. If they align, it indicates that the system is functioning as intended. Thus, you can proceed to Step 7. However, if they do not match expectations, further investigation is necessary. This step is critical as it establishes a baseline for the switch functionality and guides subsequent diagnostic actions. In the second step, after turning the vehicle to the off mode, the next procedure is to adjust the brake pedal and the brake pedal position switch. This adjustment is necessary to ensure that the switch is aligned correctly and operates in its optimal position. Following the adjustment, bring the vehicle back to the on mode and recheck the parameters with the HDS without activating the brake pedal switch again. The objective is the same as in Step 1, to confirm whether the parameter values meet expected thresholds. If they do, this may indicate the failure is intermittent and not consistently reproduced. If they do not match, further troubleshooting is required. In this troubleshooting step, you will begin by disconnecting the brake pedal position switch connector. This is crucial as it allows for a direct assessment of the switch's functionality. Following this, you will connect terminals A and B using a jumper wire, simulating the closed condition of the switch. This setup should effectively trigger the desired signal back to the PCM. Turn the vehicle to the on mode again and measure the parameters through the HDS. If the observed conditions now satisfy the expected thresholds, a faulty brake pedal position switch should be replaced. Conversely, if further issues persist, you will need to delve deeper into other potential failure areas. This step aims to identify possible failures related to the IG1 ACG wire, which supplies power to the switch. Start by turning the vehicle to the off mode. Then remove the jumper wire from the switch. Now, turn the vehicle back to the on position and measure the voltage between specified test points. These test points are critical as they allow for evaluating the continuity of power reaching the switch. If battery voltage is present at these points, it indicates that there is no issue with the IG1 ACG wire, and the next step can proceed. However, if there is no voltage, this suggests that the wire may have an open circuit, necessitating further investigation into the wiring along the circuit path. In this step, you will need to check for an open in the BK SNEC wire. Begin by turning the vehicle to the off mode and jumping the SCS line with the HDS. After waiting a moment, disconnect the appropriate PCM connector to set up for further testing. You will again connect terminals A and B using a jumper wire just as in earlier steps. Now, turn the vehicle to the on mode and measure the voltage at designated test points, which should reveal if power is being transmitted properly. If voltage is present at the test point, indicating the wire is intact, further checks may be required for the PCM itself or any other DTCs. On the other hand, finding no voltage would mean a repair is necessary for an open circuit in the BK SNEC wire. The sixth troubleshooting step focuses on ensuring proper fuse functionality. Agents will start with the vehicle in the off mode and check fuse number C30, which is integral to the brake pedal position switch circuit. If this fuse is blown, replacing it can often resolve the DTC issue. However, should the fuse be intact, further investigation is required to find an open circuit in the IG1 ACG wire between the fuse and the switch. This is crucial because an open circuit here will inhibit power delivery to the switch, thus causing the malfunction. Ensuring the integrity of both the fuse and surrounding wires is vital for making effective repairs. The seventh step carries out a secondary assessment of the brake pedal position switch. Begin by pressing the brake pedal and simultaneously checking the parameters with the HDS. This action aims to determine if the current condition reflects an open threshold signal to the PCM. If the response matches the expected thresholds, it may indicate an intermittent failure, suggesting that while the system appears functional at this moment, further inspection of connections or poor terminal contacts may be necessary for long-term reliability. Document any onboard snapshot captured by the DTC during this check for future reference. If these parameters do not align correctly, continue to the next step for a deeper investigation. In the final troubleshooting step, you'll conduct a direct test of the brake pedal position switch. This assessment is critical to ensuring that the switch itself is functioning appropriately. If testing reveals that the switch operates as intended, it signals that additional inspection should focus on the wiring, specifically looking for shorts to power in the BKSWNC wire extending from the switch to the PCM. Conversely, if the switch is determined to be faulty, it must be replaced to rectify the DTC P0703 issue effectively. This comprehensive troubleshooting is key to restoring the vehicle's proper function and ensuring safety and reliability. The final verification step revolves around ensuring that any repairs made effectively resolved the DTC P0703 error. Begin by clearing any codes from the system once repairs are completed. Following this, it is essential to take the vehicle on a test drive, allowing the systems to recalibrate under normal operational conditions. Monitoring for any DTC reoccurrences during and after the drive will provide valuable confirmation as to whether the troubleshooting and repair steps successfully addressed the underlying issue. Maintaining open communication with vehicle performance data post-repair ensures that the problem is resolved satisfactorily, ultimately enhancing the safety and reliability of the vehicle. Preventive maintenance is pivotal for prolonging the lifespan of components such as the brake pedal position switch and ensuring consistent vehicle performance. Routine inspections should be conducted on the brake pedal position switch itself to look for any signs of wear or malfunction. Checking wiring connections for any signs of corrosion or damage can preempt issues before they escalate. Additionally, fuse integrity should be part of regular checks, as blown fuses can indicate underlying wiring problems or excessive electrical load that need to be addressed. By adopting these preventive measures, drivers can enhance vehicle reliability and ensure that safety features linked to braking operate optimally. In conclusion, addressing DTC P0703 requires a systematic approach to identify and rectify the malfunction of the brake pedal position switch. Through meticulous checks of the switch, related wiring, and fuses, you can isolate the source of the problem effectively. It's imperative to conduct thorough assessments, ensuring not only the immediate issue is resolved, but also potential underlying problems are mitigated through preventive maintenance practices. By familiarizing yourself with the various troubleshooting steps, you can significantly contribute to the safety and reliability of the Honda Fit, ensuring that all essential electrical systems function cohesively. Understanding these protocols empowers technicians and drivers alike to maintain optimal vehicle performance and safety. Please like and subscribe to the channel. See you next time.